Chapter 5 takes us through queries. We've done a little bit of that, but you'll get into it in a big way with this chapter. So when you think about a query, a couple things that you're doing with that process is creating a subset of data. You're selecting information based on a specific trait. So you could look at all of the auto thefts data set in Eugene Springfield, but you may want to look at only the data that the thefts that occur on a certain day. So you can create that subset. Then once that data has been subsetted or selected, you can use that to explore the patterns and the relationships. And initially, you can just look at it and kind of do a visual exploration. Is it clustered? Is it dispersed? Is it linear? Is it within an area next to a river, floodplain, those kinds of things. And then later, you can actually run some statistical tests to see if the clustering is significant, or are there hotspots that are statistically related. Types of queries, we're going to look at two types. One is an attribute query, and the attribute query is based on a field value and a record. So I might look at income as a field in population feature data set, and I would say show me all of the income that is greater than 50,000. A spatial query is based on location of one feature with respect to another feature. So I could look at houses within a mile of a school, culverts not within 20 feet of a major river, all of the culverts that are within a county, those kinds of things. So when you do an attribute query, there's some components of the query. There are logical operators, and these are not equal to, greater than, or equal to, less than, or equal to, those just kind of mathematical symbols that you're used to using. And then there's Boolean operators, so the and, the or, the not, those kinds of terms that are used in your query. So what we're using in ArcGIS is called SQL. It's standard query language or structured query language. And in GIS, the format is that you select from a layer, so a feature, where some field, then you use a logical operator, and then you set a condition. So for example, select from cities where population is greater than or equal to 50,000. Or another query might be select from cities where population 2010 is greater than or equal to 50,000 and males are less than 50. So what you're looking at is two different fields with that second query. So here's an example of the select by attribute table, and so I'm selecting by the layer. So when I click on the layer that I want to select, then all of the field names show up. I click population, I click an operator, and then when it's a number, I can type in my value, or I can use the get unique values. Now I have a problem here in that I put a comma in this, and when I actually ran the query I got an error message, and so I had to take that comma out to run that. And then on the other example, you can see again the layer I'm using is state. I'm looking at that doesn't show what I'm looking at. But anyway, what I had selected was population greater than 700,000 and owner occupied greater than or less than or equal to 100,000. And so if I had used or, I would have gotten a much larger query. So it could have met either of my Boolean statements. So the population could be greater than that, or the owner occupied can be less than that. When I use and, I really limit my statement there. So here's some query terms and basic sentences. So let me go back to this one again. So one of the things is by using the query selector, I don't have to actually write much of this code, and so the syntax comes in correct. And I'm going to use this one because that isn't a good example. But if I don't have to say select from state where. That's already supplied for me when I choose the layer state. So all I need to do now is double click population 2010, and the double quotes are put around that already, greater than, and then the number, and here's where I put in my own error because I put a comma. If I were selecting text, these would have single quotes around the text. So let's take a look at that. So here I'm selecting from a state feature class where the name of the state, so that's a field, is equal to Alabama, so that's a text, the way text is written, and the name is equal to Arizona. So actually, if I put that query in, I would get no results because there is no state that's named Alabama and Arizona. What I really wanted to do was find a state that had the name Alabama or the name Arizona. And that way I can take the two states, Alabama, Arizona, those are selected, and I can do something with that. If I wanted to exclude Alabama, I would write not name equals Alabama. Or if I wanted to exclude both Alabama and Arizona, I would say not and then choose the field name equals Alabama and not name equals Arizona. With number fields, so again, the field name comes in with double quotes, and I can use the less than. Males under 5 is less than females under 5, so it compares those two fields and it will select any records where that's true. And it was really interesting to play with that data and find out that I couldn't find any states where males were higher than females until the age of 14 to 20, I think. And then there's some wildcard operators that you can do. So if I want to find all of the states that start with the letter C, and I'm looking at a shapefile, I would choose name and then the like operator. This is for text, starts with C, and here's the wildcard. And then I have to end it with that text operator. If I were using data in a geodatabase, it would be name, like, C, and an asterisk. Spatial queries use the logical operators, but instead of the Boolean operators, they use spatial operators. So for containment, for intersection, and for proximity. And so I'm going to put on Moodle a sheet that has all of the different ways that you can do containment. I think there's maybe 20 different statements. So completely contained, partially contained, just touches, intersects, proximity could be a distance. So there's a lot of options there. One of the things she talks about is a layer, so taking a selected feature and saving it as a layer instead of saving it as its own feature class. So once the layer or the records are selected, you can take those layers and do some mapping and some analysis on those layers as a separate layer file. And we did that in Price Chapter 4, where you did a selection and looked at, I think it was, I don't remember if it was county changes, but we used some kind of selection to look at just those changes. So the thing to remember, when you just choose it to save it as a layer, you have not created a new feature class. So if I were to take that layer and create a new field, the field would also be created in the original data set. So I'm just looking at that layer separately. I'm not actually divorcing it. So Price recommends that be used for temporary kinds of files. If I want to take that selected feature and completely separate it so that I can do some high-level analysis and send that to maybe somebody, maybe the police chief has asked me to find all of the cars that have been stolen over the weekend, and he wants to just look at that. I could select those Saturday and Sunday theft dates, save those as an exported new feature class, and then anything I do does not affect the original data layer. So when we do crime analysis in 246, I ask students to do subsets, and one of the problems that they often have is they'll do a subset, save it as a layer instead of saving it as a new feature class. And then when they try to do the hotspot analysis, they're actually doing the analysis on the whole original feature class, and so they don't see any difference. The last thing she talks about in this chapter is definition queries, and you saw this in Chapter 3 when she was mapping data. And so a definition query is done on a feature class, and it kind of defines which features will be shown in the layer. So here I have the whole United States, and I really only wanted to look at Oregon and Washington. So in the layer properties, I chose definition query, and using the SQL function, I said name equals Oregon or name equals Washington, and so these are the only two states that actually show up in my map. But you can see I have a whole country's data set underneath. So in Price in Chapter 3, I think it was mapping data, how she dealt with this is she, in the data frame, she used the clipping option. And so she chose data frame clip to shape, and then she specified shape. And then in this window that popped open, she said she just wanted the outline of the features, state name, and just the visible features. And then you can see that that's the same map, but everything that's outside of Oregon, Washington has been eliminated.